Hello class. Okay, we move to the next topic, which is capital cost estimation. Okay, once we already finalized the PFD and also the equipment to be used, we gonna proceed to the capital cost estimation to estimate the cost in building the process plant. Okay, as a recap, in process plan design, we start with the project specification, and then we perform the material balance before we perform the cost estimation in deciding which alternative should be selected based on the economic aspect. And then after that, we move to the detailed design of the selected design or the alternative that we choose after we optimizing the process. And then after that, we move to the project cost estimation to estimate the capital cost of the project. Okay, in this capital cost estimation, we consider the purchase and procurement of the equipment in the process plant. And then finally, we will proceed to the construction and start up the project. Okay, in this module, we gonna learn up until project evaluation to evaluate the project based on its profitability. Okay, these are the outline in this chapter. First, we will cover on the capital investment, what is the criteria and the item be categorized under the capital investment, and how to estimate the capital investment. And last, we will learn about the purchase equipment. Okay, the purchase equipment cover almost 50% out of the total capital cost in certain project plans. As introduction, okay, the investment and the production cost may be affected by a few factors such as the source of equipment, which the cost of the price for the equipment, it depends also on the source of the equipment. And second is the price fluctuation, because we also depending on the currency in a year, and then the company policy also will affect on the investment. And the other is operating time and rate of the production. And the last is the governmental policy such as the tax of the or the other policies that introduced by that certain country or the state. Okay, as introduction, the cost can be divided into capital and product cost, but in this part we will cover most on the capital cost. Okay, the capital cost can be classified into fixed and working capital. Okay, for the fixed cost, it's categorized into manufacturing or known as direct and indirect cost. And for the working capital that's mainly operational cost to operate the process plant, such as the cost of the raw material, the cost of the utility. So but usually the working capital cost covered within the range of 10 to 20% of the total capital investment. Okay, the total capital investment is the summation of the fixed capital and working capital. Okay, later I will explain to you the example of the fixed capital and working capital. The fixed capital investment is a total cost of designing, constructing, and installing the plant and associated modification needed to prepare the plant site, including the modification of the process, of the equipment, or maybe modification of the existing system in that certain plant or the process plant. So the fixed capital is cover all the total starting from the design until installation of the plant. Okay, example here we have this overall fixed capital investment that it can be divided into the inside battery limits, okay, based on this boundary. So for the inside battery limit, the cost is referred to the cost of the equipment, cost in operating the process plant. But for the outside battery limit or SBL, so it include the additional costs such as the utilities, the facilities, and also the fleet services that support the operation of the process plant. Okay, the detail about capital investment, which can be divided into fixed capital cost and also the working capital. The fixed capital cost is based on the total of the direct and indirect cost. Okay, for the direct cost or the manufacturing fixed capital cost is investment needed for the installed process equipment with all components needed for complete process operations, such as the expenses of piping, instrument, and site preparation. And for the indirect or known as the non-manufacturing fixed capital, which is the investment needed for a component not directly related to the process operations, such as the cost for the land, the processing building, utilities, and waste disposal. So the fixed capital cost is based on the submission of the direct plus the indirect cost. And then we have another cost under the capital investment is working capital. Okay, the working capital is the necessary for the plant operation. Usually we count in within 1 month operation, such as 1 month raw material and supply, finished product in stock, cash for the payment of startup expenses. Okay, typically the working capital is arranged within 10 to 20% of fixed capital investment. Okay, the percentage is depend on the complexity of the process plant. Okay, the more detail about the working capital. Okay, this is the financial metric which represent the operating liquidity available to a business, organization, and other entity, including governmental entities. Okay, the working capital example for the chemical plant include the raw material and supply carrying stock, finished product in stock, and semi-finished product in the process of being manufactured, account receivable, so including the supervision, the cost for the labor, so we consider as working capital. And also the tax payable that we should include this cost as a manual cost of to ensure the process plant can be operated. Okay, the next topic is the estimation of capital investment. Okay, these are the breakdown of the capital investment based on the direct and indirect cost. Okay, first we move to the direct cost. Okay, for the direct cost, it has a few items categorized under direct cost. First is the purchase equipment. Okay, the purchase equipment cover almost 50% of the total fixed capital investment. Okay, the purchase equipment cover all the equipment list on the complete flow sheet. We should consider the cost for all the equipment in the process plant, regardless whether this is the fabricated or direct purchase from the manufacturer. And then secondly, in purchase equipment installation. Okay, the installation of the equipment also should be considered in the fixed capital investment, including the structural support, installation, painting of the equipment. And then next, also consider under the direct cost is the instrumentation and control. So for each equipment and especially on the process plant related to the chemical process plant, it will be installed with the instrumentation and control. Okay, any cost under instrumentation and control should be considered, including purchasing the devices and instruments, installation, calibration of the devices, and also the computer, such as to proceed with the either PLC or TCS. Okay, DCS is the system to supervise the process plant in a control room. And then we also should consider the cost for the piping. Under the piping is the process piping. What are the type of the piping that lead to the cost of the process piping, and then the insulation of the piping itself, especially if the process operate at higher temperature and pressure to avoid the or minimize the heat loss throughout the surrounding of the system. And then next is the electrical equipment and materials such as the because for each when we deal with the instrumentation and control, okay, we also correlate it with the electrical equipment and material. To start up the PLC and DCS, we also include the cost of the electrical and equipment. Okay, these are the list for the electrical equipment, okay, including the electrical material and labor. Under the electrical equipment and material. Okay, the next is the building itself, considered as direct cost. So, and then yard improvement, if proceed with the fabrication, so somehow we need to improve the yard, including site development such as site clearing, grading, roads, walls, way, and so on. The other is a service facilities such as the utilities, including steam, water, power, refrigeration, compressed air, if we use a compressor, fuel and waste disposal. The facilities under the utilities such as the boiler, water treatment, cooling tower, and etc. So basically, the service facility also categorized under direct cost. And the last item is land. So for the land is including survey and fee for the location and the land itself, and also the property cost. Okay, for the indirect costs, okay, the items such as engineering and supervision, example, we hire the third party to perform the EPCC engineering, procurement, and process commissioning. And then the second item is construction expenses, including the permit for the labor, safety, medical, taxes, insurance, and also the interest covered under the construction expenses. And then contractor fees and contingency. Contingency is the extra added costs or the uncertainty costs until the project is completed, such as the cost for the change of the project scope, and then the cost for the change in the price of the purchase of cost, and etc. Another thing is such as the change in price due to the change of the fluctuation of the currency at the maybe because of the project is expand or we proceed with the different scope of the project. Okay, this table shows the cost factor in estimating the capital investment or total capital investment. Okay, the component for direct and indirect costs are listed here, which we can see that the highest range for direct costs obtained by purchase equipment, and the lowest is the cost for the land, which covered from 1 to 2%. And for the indirect cost, it depends on the project, and we can see that the range is within 4 to 20%. And the fixed capital investment can be obtained by total the direct and indirect costs. And then after that, we can proceed with the working capital investment, which the cost of the working capital covered within the range of 10 to 20% of fixed capital investment. And then finally, we can obtain the or estimate the total capital investment for the specific project by consider the submission of the fixed capital investment and working capital investment. So basically, in estimating the fixed capital investment. So we can use this range to proceed with. Okay, example, estimation of the fixed capital investment using range of process plant component cost. Make a study estimate of the fixed capital investment for a process plant if the purchase equipment cost. Okay, so the purchase equipment is 100,000 USD. So the estimation is because the range is within 15 to 40%. So we may consider average of the range for the purchase equipment. It gives about 25%. And then we can proceed to the next item until it gives us the value of fixed capital. So the total is fixed capital cost. So we can obtain this value, and then the rationale is you may calculate the rationale by consider 100,000 over 436 to get the rational percentage. Okay, the capital cost estimated can be categorized into 5 types. So first we have order of magnitude estimate. Okay, the accuracy is within minus 40% to 40%. So it can be applied to the extrapolate similar plant cost. Example, we be assigned to estimate the cost to build the ethanol process plant. So using the same existing ethanol plant, so we may extrapolate with the similar plant cost. This type can be proceed for the process modification. And then for the next type is the study estimate, and then the accuracy within plus minus 30%. And then we can apply the study estimate once we have the knowledge on the major pieces of the equipment by referring to the PFDO cost chart or consider as pre-design stages as well. The next type is preliminary estimated. The range is plus minus 20%. Okay, it can be applied when we have enough budget authorization. That's maybe the owner of the company or the top management provided it the budget or the estimation of cost to start up the plant. Okay, what the FEMA required are PFD versus cash and the equipment diagram. Okay, the next step is definitive estimate, which the accuracy is higher from plus 10%. It based on the basic engineering codes from the supplier and contractor. That's mean we obtain the actual codes from the supplier and contractor. So it requires the PFD versus test and also the preliminary isometric diagram. Okay, the last is the detailed estimate. So it has the most higher or the most accurate percentage. Okay, it based on the detailed engineering design. So to proceed with the detailed estimate, we require the detailed engineering design. That's mean project is ready for construction phase. This is the summary on the capital investment cost. So we gonna use the estimation based on this abbreviation. So you can see here we have total bare cost for fabrication denoted by CFE, and then we have the total bare module cost for process machinery CPM. For the spare we have C spare. So C is the cost. So TBM is the total bare module investment. Okay, we gonna refer to this bare cost if we do not have any reference or the diagram to be referred to estimate the purchase cost. Okay, I will show to you the example later. Okay, for the factor estimate, the total plant capital cost or CPM or the fixed capital investment or FCI can be estimated using a factor estimate. Okay, in factor estimate, one estimate the cost of individual of the piece of the equipment, and then we can estimate the total installed cost by the multiplying the factor. Okay, for the cost component in capital investment, okay, this is the most common or the important method to be used in estimating the cost of the purchase equipment. Okay, this is because we tend to develop the purchase cost as accurate as possible by considering factor cost. Okay, all other items can usually be estimated as a ratio of purchase equipment cost. So the first is to develop or to define the purchase equipment cost before we can proceed to the other cost. So usually we can use the existing or all data for similar equipment. Example, we estimate the cost for the pump. So we have the data from the previous project. So we gonna use that data by using the factor. Example, based on the capacity factor or the inflation factor, or called as the cost indexes. Okay, for the cost indexes, it based on the time effect, and then for the scaling factor, it based on the size effect. Okay, example for the size effect. Okay, to purchase pump or to estimate the cost in purchasing pump, so we the reference cost is used for the example for 10 horsepower, but for our project we require it for maybe 20 horsepower. So we can use the scaling factor to estimate the pump for the current project. Okay, for the cost indexes, we're gonna refer to the typical cost indexes used in the industry to be compared with. Okay, I will show to you the example for you to more understand. Okay, first we proceed to the effect or size, or known as the based on the capacity factor. So example, okay, CA is the cost for the desired equipment or the existing project. CB is the from the previous project. Okay, example, the equipment used is the pump. So we have CB from the previous project and CBA pump from the for the current project. So we have cost for the CB, that's mean from the previous project. Okay, the capacity equipment is over the capacity equipment in project for the previous project times to the scaling factor. Okay, the typical range for the cost of exponent is from 0.5 to 0.8, but usually we gonna use 0.6 as the reference or typical value, or this is based on the 6-10 rule, or 6-10 rule can be used to scale up an entire process. Okay, example here. Okay, we need to determine the heat transfer area for the heat exchanger, and then we can obtain example from the current project. The area is 500 degree. So we can use this scaling factor in based on the slope of 0.6. So we can obtain the purchase cost for the heat exchanger by using this diagram. Okay, but please be ensured that you refer to the current, the latest year. Okay, since this is the not updated year, so in 1990, so you may use another the latest diagram to determine the purchase cost. Otherwise, we can use the cost indexes. Okay, these are the typical exponent for equipment cost versus the capacity. So we have the list of the equipment such as blender, blower, centrifuge, crystallizer, and etc. Okay, this is the size range. So you refer to what kind of the equipment. Example, your equipment is the heat exchanger and shell and tube, and ensure this is within the same range. and then you can choose the exponent of 0.60. Okay, let's take a look on the example. Okay, a new plant ordered a set of floating heat exchanger. Okay, the area is 100 m square, cost 92,000 USD. What would cost be for a heat exchanger for similar service if area 50 m square and is the cost exponent is 0.44. So the example consider we have CA. This is the current cost required. So the CB is 92,000 times, okay, times the required area is 50 over 100 and exponent is 0.44. So we can obtain the cost for the current project is 67,816.38. So this is the cost for the current project with the area is 50 meters square. Okay, the cost change year to year or increasing due to the inflation. Okay, inflation is measured by cost indexes. Okay, the typical cost indexes for the chemical process plant such as we have CE, Chemical Engineering Plant Cost Index, Marshall and Swiss or MS Equipment Cost Index, and F Nelson-Ferrer Cost Index, and also Engineering News Record Construction Cost Index. Okay, this is the ratio based on the purchase cost for the existing to the previous project to the current cost index to the previous cost index. Okay, so the cost index usually will be revised every 5 years to ensure we have this updating cost to be compared with. Okay, these are the example of the cost index. Okay, until 2004. So in your design, you should refer to the latest cost index. Okay, so we have the value of the cost index based on MNS CE of Nelson-Ferrer. So you may choose either one to be referred. Okay, example, a centrifuge cost 95,000 USD in 1999. What is the cost for the same centrifuge in the third quarter of 2004? Use CE index. Okay, for the CE index in 1999. So 1999 for CE, so the cost is about 390.6. Okay, the third quarter 2004, so you may refer to this value. And then using the equation of C2 over C1, I2 over I1, we can obtain the C2, example C2, so C2 over 2, I2 over I1 times C1. So inserting this value, and then we can get the cost in 2004 is 111,000. Okay, the cost in that is based on the inflation or the increase in price of goods without a corresponding increase in productivity. So you may determine the inflated cost using this formula. So it based on the year 1 inflation rate, year 2, year 3, and also based on the base year. So base year, that's mean the reference year that you refer. Okay, next topic is estimating capital cost. Okay, as introduction, this part will cover on the accuracy, rapid cost estimates, factorial method of cost estimation, estimating purchase equipment cost, and cost escalation. Okay, for the accuracy and the first. So we have, okay, in process design, we start with the conceptual, detail design, procurement, construction, and operational. So the accumulation cost shows that the higher at the accumulate until we can operate the plant, the cost of the operation. And then the influence of the decision is based on the higher from the conceptual design. So that means we should have the correct design or the correct conceptual design before we can operate, because it will affect on the decision of the project cost. Okay, the first is rapid cost estimation based on the historic cost data. So if you can see here, basically it refers to the scaling factor that we compare the capacity to the cost of from the previous project and the power of the correspondent. So this is known as the historic cost data. Okay, the next is using the step count method. Okay, the step count method is used if we do not have the available data or the based on the similar process. So by using this method, we can add a contribution for different plant section. Okay, factors are usually included to allow for the capacity and complexity of the process, such as the material of construction, yield, operating pressure, and temperature. Okay, for the plant, primarily processing liquid and solid using the bridge water method. If the capacity is higher than 60,000, the cost may be referred to this equation, which is the number of functional units times the capacity over the reaction conversion times the fixed cost exponent here. But if the capacity is less than 60,000, you may refer to this equation. Next is another process plant, such as related to the manufacturing process, or known as the manufactured product. Okay, for the large scale production, example higher than 500,000 pieces per year. Okay, the rule of thumb is the total capital operational is equal to the 2 times material cost. Okay, this equation can be used to make a very approximate estimate of the plant cost if fixed costs and utilities can be estimated. Okay, however, the most typical method used is based on the factorial method of cost estimation. For the factorial method, the capital cost estimates for the chemical process plant are often based on the estimation of the purchase cost of the major equipment, because it gives us the higher range on the total of the capital cost. So we may refer to the major equipment first and then use the range to determine the other additional costs, such as the purchase of installation on the piping, instrumentation, and etc. Okay, the accuracy of the time estimate will depend on what stage the design has reached. So usually to come up with the factorial method, we should at least perform the detailed design, because it requires the properties and the specification of the equipment to be compared with. Okay, in factorial method of the cost estimation, there are a few methods that we can use. The first is based on the length factor. Under the length factor can be estimated, okay, by multiply the installation factor to the total of the cost of the equipment. So C is the total plant of the internal or the inside battery limit. Okay, for the length factor, it depends on the processing plant, whether solid, fluid, or mixed. So you can use a salad is factor or installation factor and times with the cost of the equipment to give you the total cost for the inside battery limit. Okay, the table 6.3 is the example of the installation factor for the different type of the equipment. So for each equipment, it has own installation factor. Okay, for the detailed factory, estimate it based on the direct cost, which the direct cost item that are incurred in the construction of the plant. In addition, the cost of the equipment such as the equipment erection, piping, electrical power and lighting, instrument, process building, and so on. So we can detail the cost of the direct cost to increase the accuracy of the estimation in the capital cost. Thus, for the detailed factorial cost, we consider the other factor to be included in determining the cost of the major equipment such as equipment erection, piping, instrumentation, electrical, that each own processing plant, such as the processing plant based on the fluid or the fluid solid or the solid, it has own factor. Okay, the total or the ISB inside battery limit cost or denotes by C can be obtained by multiply the factorial to the equipment cost of the equipment, and then we can also consider the outside design engineering and contingency based on this factor. Okay, the total fixed capital cost can be using this equation or based on the cost of the cost to the outside design and also the contingency, or you can times with this factor. And also to be more accurate, you may also consider the cost of the fixed capital based on the submission of the major equipment times its factor list here. We have listed the factor here based on the processing plant. Okay, the detail of the equation to determine the cost based on the cost of the equation, whether using a carbon steel or alloy, using this equation. Okay, and then the value or the factor for the FP is the factor or installation factor for the piping, for the material, and so on. You may refer from this value. Okay, table 6.5 lists the factor material to be used based on the process, whether the material is using the carbon steel, aluminium, cast steel, or so on. So you may insert this value to this equation that represent or denote by Fn or the factor material. They're using this equation or using another equation based on the purchase equipment type, whether using an alloy steel or carbon steel or alloy. Okay, in estimating the purchase cost, so we will focus on the how to estimate the purchase cost. Okay, the first using this equation by consider the scaling factor on the size parameter using this table. So you may refer to this and compare with the existing equipment of the current project. Example, your equipment is a propeller. So what is the size? Okay, the range is lower to the upper, and the value, you may insert the value of A, B, and N here to this equation before we can obtain the estimation cost for the equipment. Same goes to another equipment such as crystallizer. So ensure the range of your or the size for your equipment, and if the lower is 7 and then the upper is 280, you may use this value to be inserted into this equation. Okay, the cost of the building a plant in any other location will depend on the local fabrication, local labor, cost of shipping or transporting equipment to site, import duty, and currency exchange rate. So the location factor also can be considered in obtaining fixed capital cost. So the location factor here given in this table. So example, if your project is located in Germany, so you may use this data or the location factor before we can finalize the fixed capital cost of the processing plant. Okay, example, the cost of constructing a 30,000 metric ton per year of acrolein plant was estimated 80 million on 2006 US Gulf cost basis. What will be cost in USD on 2000 Germany basis? So the location in German. So from table 6.7 here in 2003. Okay, because okay, maybe this is not mentioned, but based on the given problem here, it mentioned about 2003. So I presume that the table 6.4 is based on year of 2003. So the in 2003, in Germany, the location factor is 1.11. So 1.11. So the exchange rate in 2000 about £1 to USD. Okay, this is the exchange rate, and then the average about $1.35. So in 2006, so the location factor for Germany is okay. This is 2003, and then times the current currency exchange in 2006 over in 2003. So we can get the factor for the in 2006 for Germany is 1.3, and then times with 80 million, you can get the cost in a German in 2006. Okay, next to estimate the purchase cost. Okay, so we will move in detail how to estimate the purchase cost, because if we have more data or refer to the more accurate data, so we can get the cost of the process plant is closely to the actual cost. Okay, example for the pump. Okay, this is the equation to determine the purchase cost of the centrifugal pump by consider the factor of the type, material, and also the best cost. Okay, example here. Okay, the purchase cost based on the free on board. Free on board, that's mean the risk can be taken by a seller after the equipment is shipped out. Okay, the material given in the table 22.21, and then we can determine that the material factor based on the material construction of the centrifugal pump, whether the pump is cast iron, cast steel, bronze, and etc. And the table below here is referred to the type factor for the pump. That means we should determine the flow rate, pump head, the maximum motor or the horsepower of pump that give the value of FT. And then after that, inserting this value into this equation before we can obtain the purchase cost. So the CB you can obtain from this equation, that S is referred to the size factor or based on the equation of capacity times the head, pump, and also the exponent cost. And then for the electric motor, you may refer on the factor of the type and also the best cost. Okay, for the best cost, you may refer to this equation, and PC is the power consumption. Okay, for the type of the factor for the electric motor, you may refer either the motor is based on the explosion proof enclosure. So usually this of the electrical motor can be used for the critical process plant that should ensure it has higher safety aspect. And this range is based on the rotation or the RPM of the electric motor. Okay, this is the best cost. If we not consider on the equation, you can also determine the best cost from this figure. Okay, the purchase cost is the CB or the best cost. So that's mean it refers to the properties of the electrical motor. So the best cost is based on the properties of 3,600. It gives you the best cost, and then inserting the value of CB to determine the purchase cost. Okay, the diagram is based on 2006 or the cost index is 500. Example, the CB for the A or the best cost for 2006 and you required to determine for the cost in 2020. So based on the scaling factor CA over CB over IA over I equal to IA over IB. So CA is the required base cost. IA over IB times CB. Okay, IA is the year in 2020. Example, the index is 900 over 500. Okay, this is the value times the purchase cost or times the best cost in year 2006 referring to this diagram. Example, the size factor of your equipment is 10. So drag this line, it gives the value of maybe 900 US. So the cost is by calculating this value, so we can obtain the best cost in 2006, and that is setting this value to this equation. It gives you the purchase cost of the electric motor. Same goes to the gear part, but it based on the factor type, and also the best cost can be obtained using this equation. And also you can also refer to this diagram, but ensure the properties given in this diagram is based on the condition or the properties of your project. Okay, for the heat exchanger, so the equation is based on the factor pressure, factor material, factor of the tube length, and also best cost. Okay, for the best cost, you may also refer to this diagram based on the type of the heat exchanger to give you the base cost. And then finally, we can obtain the purchase cost. Okay, referring to the scaling factor, example, your project in 2020, so CA equal to IA over IB times CB. CB is in year 2006 to give the value in 2020. So, or otherwise, you can use this equation to obtain the best cost. Okay, next we move to the other type of heat exchanger. Okay, this diagram for the double pipe heat exchanger, but for the carbon steel and pressure to 600 PSI only. And the cost is based on the 2006 and the cost index, and the cost index is given. Okay, for the another type is the fire heater. So you may refer to this diagram to obtain the CB before we can determine the CP of purchase cost. Okay, how about for the pressure vessel and tower? So it based on this equation or the material factor times the vessel cost of the vessel times the additional cost, such as if the tower is the absorption. So for the absorption, we may consider the packet cost of the packet material inside the tower. So it gives you the value of CP or the purchase cost, or you may refer the value of the best cost from this diagram as well. So these are the additional information to determine the CP or the purchase cost for the tower based on the vessel and additional. Okay, for the vessel, the range or the weight is given here. That means you should determine the weight of the tower before we can use this equation. And for the other additional costs, you may refer to these properties based on the internal diameter and the length of the tower. Okay, this is the summary in estimating the total capital investment by using the factorial estimation to estimate the purchase cost equipment. Okay, first we need to prepare the material and energy balance, and by finalizing the PFD, and then define the size, measure equipment item, and select the material of construction. Example, if we estimate the purchase cost of the heat exchanger, so the selection is based on the surface area. So you need to perform the detailed mechanical design first before we can proceed to the estimate purchase cost of the major equipment. Okay, example, if we estimate the purchase cost of the distillation column, so we should consider the cost for the vessel, and also since it involves the column, so we should consider as well the cost for the column. So the purchase cost of the equipment, it depends on the type of the equipment to be estimated. And then after that, we may proceed to the calculating the inside battery limit of the capital cost, and also the outside battery limit of the capital cost, such as the engineering and contingency, if it depends on the specification of the project assigned to you. And then after that, both ISBL or inside battery limit and outside battery limit to give the total of the fixed capital investment. And then after that, we may estimate the working capital. Typically, the range is between 10 to 20% of the fixed capital investment. Okay, the range, it depends on the complexity of the project. And then after that, we may add both fixed capital and working capital to obtain the total capital investment required in the process plan. Okay, and then after that, okay, this is the summary for the production cost. By consider the variable cost, including the material, miscellaneous material, utilities, and shipping packing, and then the fixed costs such as maintenance, operating labor, and then the percentage is given here. And then total the A and B give you the direct of production cost. And then for the indirect production cost, this is indirect. For the indirect production cost, including the sales, overhead, and research development, it gives us the annual production cost before we can obtain the production cost per kg, or based on the annual production cost over the annual production rate. And then how about the cost of utilities? Okay, these are the list of the cost of utility based on the UK and US. So you may refer to this cost based on the rate, based on the ton or the metric joule. So it depends on these properties. Okay, let's refer to this example. Okay, preliminary design work has been done on the process to recover a valuable product from an effluent gas stream. The gas will be scrubbed with a solvent in a packet column. The recovered product and the solvent separated by distillation, and the solvent cooled and recycled. The measure of equipment that will be required are detailed as below. Basically, from the process description, it gives us the major equipment required in the process, such as absorption column, recovery column, reboiler, condenser, because we have the column. So eventually we're going to have the reboiler and condenser, and also the cooler, since it mentioned about the cool here, cool process, and also the storage tank to store the product. So the detailed properties such as the dimension and also the other material, including the type of the vessel, the operating condition, and the support vessel also given. And then finally, we can obtain the purchase cost. Okay, so referring to the table to obtain the bay cost. Okay, so CP equal to CB, FM, and also FP. We can give the the cost for the vessel, and then since the absorption column require the packet item in the column, so consider the cost for the packing material, and finally we can determine the total cost of the absorption column. How about the recovery column? The method same with the absorption column, but it based on the plate. So you should consider the cost of the plate. It give you the total of the column. Okay, the next equipment is the reboiler using CP equal to CB times FP and FT. So it can give the value of the purchase cost. Same to the condenser, we have CP equal to CB and FT and FP. It gives us the value of purchase cost, and also the cooler, solver tank, and product tank also can be obtained from the, okay, for the solver tank and product tank, you may refer to the table that give this based on the scaling factor. And since the tank having the same cost, so you may refer to the product tank, you may refer the cost for the solvent tank. So it has the same cost. And then after that, total the purchase cost for the major equipment. So this total, and then after that, using this equipment or the total cost by consider the factor of the equipment erection, piping instrument, or depend on the processing plant, whether this is the fluid, solid fluid, or the solid. So referring to this, so all the factor, it depend on the process plant. Example here, the building is not required, utility is not applicable, and also the storage is already provided on the major equipment, and the site development is not applicable, and also the other criteria. So it based on your project. And then after that, the total physical cost, you may use this equation or the CE, total CE times order plus F, okay, 0.4 is FE, and then plus FP and etc. And then after that, this is the indirect cost, also should be considered before it gives us the value of the fixed cost from the, and then after that, consider the working capital, which is about 5%, and then after that, it gives us the value of total investment required of total capital investment. So this is the total investment capital. Okay, in this example, it also estimates the product cost, which consists of the variable cost and fixed cost to give us the direct production cost. Okay, you may refer to the detailed information here. And then finally, we can determine the annual operating cost from this addition of the by total of the variable and the fixed cost. Okay, let's take a look on the another example. If the estimation of the total capital investment based on the cost index. Okay, the detail of the cost is based on 1099, and then the project is in 2009. So how can we obtain the purchase cost in the year of 2009? Okay, by using this scaling factor, so we can get the cost of the equipment. Example here for CSTR, and then the cost constant is given in 1099, and then after that, insert all the information to give us the value of purchase equipment of the CSTR. And then since the year in 1099, so we can using the cost index factor to estimate the cost in 2009. Okay, the next equipment is distillation column. Okay, for the distillation column, it consider the cost of the condenser and reboiler as a one package. And then using this information, since the vessel cost is a given, and then we can obtain the cost of the vessel by using CE equal to CB FP FM, or the factor material and also the pressure factor. Okay, since the distillation column is using the sieve plate, so the cost of the one plate is given, and then using the material factor we can obtain the cost for one plate, and eventually it gives us the total cost for the how many plate required in the process, and then comparing it using the cost index to give the purchase cost of the distillation column in 2009. Okay, for the condenser, we can obtain the cost of the condenser using the factor material, or the CP equal to CB, CM, FM, and FP. And then finally, we can obtain the cost of equipment. And in 2009, for the reboiler, it has the similar step to determine the cost of reboiler with the cost of condenser. Okay, the next equipment to be estimated in this example is the distillation column. Okay, for this equipment, it also uses the sieve plate, same like the previous column. So the total cost in the distillation column, or the package of the distillation column, including the cost of condenser and reboiler. So for the column itself, we must include the cost for the column and plate. And then after that, using the cost index to determine the cost, or the total cost of the distillation column in 2009 by comparing with the cost index in 1999. And then for the condenser and reboiler, it used the same method, which is considered the cost of the equipment by considering the pressure factor and also the material factor. And then after that, we can determine the cost of the condenser in 2009 by comparing with the cost index in 1999. Okay, the method for the reboiler also the same like we did in the condenser. Okay, the next equipment, or the major equipment in this example, is a gravity separator, and the unit is 2, and then after that we can obtain the cost of the 2 unit for the gravity separator. Okay, this is using the same method. Okay, since it has another column, and then after that we have pump. Okay, the cost for pump also given here based on the cost index. Okay, in this example, okay, it has the pump in 2008, and then after that we can use the cost index to obtain the cost of the pump in 2009. Okay, for the reactor, it use the equation of the scaling factor, and then inserting all the information based on the scaling factor, including the cost exponent, to give the information or the estimation cost for the reactor. And then after that, since the cost is based on 1099, so we can compare it based on the cost index to obtain the cost of the reactor in this project in 2009. And then next equipment is the mixture, and then using this, okay, it has the cost of the mixture in 2009, so we do not require any cost index to be estimate. Okay, next for the heat exchanger, another equipment in this example. Okay, it has the detailed design of the heat exchanger is given here, and then the purchase cost of the heat exchanger can be obtained by using the cost index. And then after that, by calculating the number of the heat exchanger required in this project, and then we can obtain the final, or the total purchase cost of the heat exchanger. And then for the liquid extractor, it has the cost of the liquid extractor is given here. Okay, and then the next is to list all the factors considered in determining the purchase equipment, and then using this, okay, PCM is the purchase equipment, and then these are the factors. You may refer to the table, and then finally we can get the total physical plant cost or the purchase equipment times the 1 plus all the factor here. Okay, all the factor, it depends on the project. Maybe some of the project do not require the utility, storage or site development. It depends on the specification of the project. Okay, in this example, it also consider the indirect cost. Okay, this is the factor for indirect cost, and then it gives us the value of the fixed capital by consider the indirect cost for to obtain the fixed capital in this project. Okay, this is the total purchase cost for each equipment that have been calculated earlier, and then this is the total purchase of the major equipment, and then using the factor for each component listed here. Okay, this is the total factor listed, and then finally we can obtain the fixed capital. Okay, to obtain the initial investment required, okay, since it not consider on the working capital because it consider only the initial investment, so we can also consider based on the fixed capital. So this is the total initial investment required for this project. Okay, I summarize all the information given in this chapter. Okay, first we have learned about the component in direct and the indirect cost, and then what is the fixed capital cost. Okay, the fixed capital cost can be obtained by the total of the direct and indirect cost. Okay, for the direct cost, the main cost involved is the estimation of the purchase equipment or the purchase of the major equipment. So in this chapter, we also learn how to determine the purchase cost of the major equipment by using either the cost index or a scaling factor. And then after that, we also learn about the total capital investment. Okay, the total capital investment is based on the submission of the fixed capital cost and also the working capital. Okay, once we already determine the fixed capital cost, we can define or estimate the working capital by using the range of 10 to 20% of the fixed cost. And then finally, we can obtain the total capital investment. This is how we estimate the investment or the capital investment in this project. And then for the next topic, we're gonna learn how to evaluate the project based on the cost estimation. So see you for the next chapter. Okay, thank you for your attention. Bye.